Testing. So how's everybody in chat today? How are we doing? Are we holding up? Have we gone insane yet? Hopefully not. I mean, after all, this is only the second week. Well, it's 1:30, and I don't see any reason to delay. Hello and welcome to this, our, I don't know, 4th or 5th live stream for the CO02 section of Computer Science 1MD3, a course on offer from McMaster University. It is my observation that I haven't actually at any point said that this is a course that's being offered by McMaster University in Ontario, Canada, for the purposes of the posterity of anybody who might be watching this who's not actually in the course. Anyway, yes. Today that we are going to be talking about dates. We're going to be talking about how to get a date. No, we're going to be talking about how to encode dates, not how to get dates. That's a small joke. So, dates. Dates are a thing that we commonly have to deal with in a society. It's sort of elementary school material for most people. There are many different calendar systems that exist in the world, but we're primarily interested in the Gregorian calendar system. However, the calendar systems have a large number of different complicated things that they have to take into account. Daylight savings time being one, although thankfully not every region has to deal with daylight savings time. I'm hoping that at some point Ontario can go the way that the Yukon went this year and just get rid of it entirely. We also have leap seconds and leap years to be taken into account. We have time zones to be taken into account. And of course, all kinds of different regions in the world just write their dates differently. So if you want to go from largest to smallest, year, month, day, you are looking at such places as China and Japan, and I think Switzerland, and one of those countries up there in the Baltic region, and I think that's Iran, possibly. I could be wrong. If you're looking for day, month, year, smallest to largest, that's most of everybody. So South America, Russia, most of Europe, Australia, India, and Greenland. The Americans, for some reason, are the only people who do it month, day, year. And a number of places have it in combined formats. We, Canada, are the only place in the world which uses primarily all of them. So, hooray for Canada. Diversity is our strength. So, when you are encoding a date format, something formatted that should be a date in Python, there is, in fact, a very specific module which was touched on in the previous sets of slides, which provides a lot of that type of functionality. This is datetime. So this is a module that contains a number of different classes. You've got datetime.date. This is a class for representing specifically dates, so years, months, and days. You've got datetime.time, a class for representing time on some day, doesn't matter what. That is hours, minutes, seconds, microseconds, and time zone, the way that that's encoded. If you wish to combine both into one class, then you have datetime. Datetime, of course, is a class which inherits both date and time. And then you have time delta, which is a class representing a difference between two datetimes objects for the purposes of arithmetic. Is chat alive? I haven't seen any chat from chat today. Yes. So, if we wish to create a datetime object, it's reasonably simple. Boop. Nope. Herp. Herp. There we go. So, from datetime, import datetime. If you want to acquire the current date and time and assign it to something, so this moment is equal to datetime.now, print this moment. There you go. You can see this was called on a precisely precisely 5 minutes past the half hour. So an interesting thing about this is that if you delay the calling of this, you actually get exactly the same moment. So it's not that we are always, it's not that we are making this moment into a thing that is always the current time. We are assigning it to the time at the time that that function is called. So that's a reasonably important distinction. So we can say that the midterm, or test 3, is datetime. We have a constructor for the datetime class. It is 2020, 3rd month, 31st day, 9th hour, 0th minute, 0th second. The time left between those is test 3 minus this moment. And so if we print the time left, we have precisely 6 days, 19 hours, 20 minutes, and 2 seconds before the midterm. Haha. So get studying, folks. So there's also this sort of issue of converting it to a readable string. With respect to if you guys, this slide here where most people across the world have different ways of doing this than most others, although, there seems to be a reasonable degree of agreement that day, month, year is the way that it should be done. You know, you may at some point be needed to format a string according to a date. So in order to do that, we create a string that contains the formatting options. Then we can rearrange them however we want. So if we want to print test3, we're using a function called strftime, or string format time. Give it a string that contains all of these string formatters. So these %, then character groupings, these format different data types. So year is capital Y, lowercase m is month, lowercase d is day, uppercase h is hour, uppercase m is minute, uppercase s is second. And there you can see that formats it the way we want. However, if we want to have this understandable to a person from the United States of America, you want to put the year at the end of the string. And you can see that is precisely what it's done. There you go. And you don't have to just, you can spice this up with some more stuff. So I have a question. Why could I call date time and not datetime dot datetime? You're speaking about this here, I presume. So this is because this is a class constructor. You remember the init functions that we used when we were doing classes? This is a calling of an init function, but for the datetime class. So you don't need to do datetime dot datetime in that respect. Hopefully that answers your question. So yes, you can add additional stuff, such as, and it is and capital A formats the name of the day. So, and it is a Tuesday, and you can see my string is cut off there, but whatever. So, similarly to how we can convert a date-time object to a string, we can also convert a string to a date-time object. However, we need to be able to tell the algorithm the manner in which the date has been encoded in the string we're reading. So, for example, if we have a string, call it, Numpy's day, and that is March, how about the 1st of May, 1927. Now, if we want to convert this into a date-time object, pardon me, then we invoke a different method. We use strptime rather than strftime. We give it the string that we want to convert, in this case, Numpy's day, and Then we give it a string with the formatting inside of it that will convert this into the datetime object. So we have the day, which is lowercase d. We have a space, then we have the title of the month. Now, title of the month, we haven't done this yet, but that is lowercase b. Then we have a comma and a space, and then we have the year, which is uppercase Y. And then if we wish to print, we can see that what it has done is it has read in the data in the string, and it has converted it to the sort of regular date time format. And of course, you could do this with any number of things. Jolly Day is the 17th of June 1982. And we can, we got a value error. Oh yes, okay, so it has to be the 3-letter acronym for the month name. But there you go. Very cool. And that's called parsing. Parsing is cool, but it's, a reasonably complicated topic. Anytime you're taking a string and interpreting it to get the data out of it, that's called parsing. So, sometimes we have to deal with time zones. Time zones are terrible. You can never remember, unless you fly a lot, what time zones actually do. Python datetime objects can have a time zone set for them, and then it is possible to convert between one time zone and another, but we're not going to require you to do that in this course. So it is recommended that all Python datetime objects are kept in universal TC, whatever TC. I know the U is universal time. Universal time constant? I don't know. Then, when you want to print it, convert it to the relevant time zone. This is easiest to do using an external package, pytz, to help with the time zones. This can also handle daylight savings, time, leap years, etc. GMT, oh wait, it's at the bottom of the slide, Jesus Christ. So GMT is Greenwich Mean Time, which is where the prime meridian goes through, and UTC is Coordinated Universal Time, which is generally accepted as an international time format. Yes. So basically, and this is if you think about it, this is exactly what the Jupyter Hub server does. Is when you have when you have timestamps on your submissions for assignments, those timestamps are expressed in UTC. So it's very common for servers. So here's a somewhat complex example involving time zones. There we go. So let's try her out. From datetime, import datetime, time delta, import pytz, time zone is equal to pytz dot time zone Canada / Eastern before, and I'm just going to copy that. This is our before time. 1 second is equal to time delta seconds equals 1. After is equal to before plus 1 second. we have the format string expressed separately here. And we will print before dot as time zone tz dot strf time format, and then we are doing the same thing with after. And if I've entered everything correctly, something should happen. There you go. So, as you can see, we have changed, we have not only added 1 second, which has rolled us over from 1:59:59 to 2 o'clock, should be in Eastern Standard Time. And when we move from Eastern Standard Time to Eastern D time, I forget what the acronym means, we, of course, gain 1 hour, which changes us from 2 to 3 o'clock in the morning. Very cool. So, and then we've got an even more complicated example, which is another one of these Trump tweets. You can you can get out of this data which day of the week it has been written on, because if you take a look in the data, there should be a actual time. Yes, here it is. So you can take the timestamp that that this tweet occurred on, read it in as a time object, and then get what day of the week that was, which is interesting. But I'm not going to do this example on. I'm not going to do this in Jupyter. So yeah, that is dates. Very short unit, but interesting and useful information. Are there any questions about it? I will wait for questions and at the same time change to the next set of slides. That was topic 10.33. What is JSON? JSON is JavaScript object notation. I would recommend knowing that for the test. If you remember, when we covered 4 major file formats during our unit on file I/O, we did CSV files, comma separated value files. We did JavaScript object notation files, or JSON files. We did XML, which is extensible markup language, and we did HTML, which is hypertext markup language. So if you're having some, if you're wondering what a JSON is and what you should be doing with it, then I highly recommend taking a look at some of the other stuff. Can I go over how pi_tz.timezone method works? Yes, so what it does is it creates a it creates an object which encodes the information for a particular time zone, and then that is feedable into datetime object. You set the time zone info parameter equal to pi_tz.utc, so you have things encoded in whatever it was. coordinated universal time. So it's mostly a matter of generation of and use of a class object. Now it's reading in a string here, and there are likely to be a large number of different strings that you can access in this pi.pytz. I highly recommend taking a look at the documentation for a complete listing of them. Hopefully that answers your question. So let's move right along. So we're definitely entering into the sort of class winding down, extra topics sort of territory here. The next set of slides is on the subject of databases. Now, this is going to be a somewhat radical departure from the types of material that we've been dealing with so far, as the database material does not even use Python. We will not be using the Python programming language to do databases. We will be using a language called SQL Lite. Databases are a manner of holding data, large quantities of data. But if you take a look at a large number of the types of positions that you might be interested in applying for, if you're interested in applying for positions within the fields of computer technology, computer sciences, programming, data entry, all of these type of things, some knowledge of databasing is not going to be optional. So it is useful, even though this isn't a topic that is covered. Like this is not a topic that appears in the calendar description for this course. But since we have the time, and since it is extremely useful information, and since the level of skill that you need with computer programming to be able to use this stuff should be about where you are right now, let's talk about databases. So, like a programming language, databases are fundamentally a method of accessing, storing, and processing data. However, there are a few key differences. With a database, data is stored in dedicated files and loaded as needed. The data can be a lot larger than the available memory. So think retailers, catalogs, bank accounts, personnel records, or Twitter. There's no need to explicitly open files and read data. So generally speaking, this is all handled for you by the database querying system. So what we are doing here is we're not learning how to construct a database from nothing. We are learning to use databasing tools in order to create a database. We are going to be using SQL Lite, as I said earlier. So the data can also be accessed simultaneously by clients, either locally or remotely. So there's an element of networking that goes into this. You can think of it as a server and a client. So, and that's a little bit of networking jargon for you. Generally speaking, servers are the things that serve the clients. Clients are the things that access the servers. So right now, you watching this video, you are a client accessing YouTube's server. The YouTube server is the thing that I am accessing in order to put my live streaming information into it. I'm actually using what's called the YouTube primary ingest server. So the data inside of databases is atomically updated. So data is either stored or not, but it never becomes corrupt, even in the case of failure, disk error, network disconnection, or what have you. So atomic, you can think of atomicity in the same way that you would think of it with respect to actual atoms. The term atom derives from the idea that atoms are the smallest thing, the smallest unit of matter. This was what was believed of atoms in the early days of, you know, submolecular physics. It was later a big discovery that atoms were composed of things that were smaller than atoms, because it meant that atoms weren't the smallest thing, and that the Greeks were wrong, although not really. But anyway, atomicity. Data must be structured in specific ways, for example, in tables and in relational databases, and you can write complex queries. So when you are interacting with a database, what you're doing is you're querying, you're writing a query. You are writing some code that requests some data or adds some data or manipulates the data in some way. So with respect to, So I think what I'm going to do right now, rather than continue on with the slides, is I'm going to show you guys how you guys can get SQL Lite and use it for yourselves, because I'm going to be doing some stuff in this lecture and in the next few lectures which involves using SQL Lite, and I'm just going to show you how to get it. So if you go to the Googs, search up SQL Lite, go to SQL Lite homepage. Oh, there is not two L's. It's SQL Lite, actually, technically. So if you go to download, now this will depend on your platform, but if you're working on Windows, what you do is you want to go to SQLite Tools Win32 x86, download this package. Once you have downloaded the package and extracted it, you'll get something that looks like this. If you run SQLite 3.exe, you will get the following window. Now, I'm not going to worry too much about where the data is being stored, since I'm not interested in storing the data. This is just for the purposes of demonstration. But this is your command prompt for SQLite that we're going to be using in the next little bit. I have a question. Question off the current topic. Is there a way to use various objects of a class in code? For instance, would we create a file? So, Mr. Grigosta, I have a question pursuant to your question. What do you mean by use various objects of a class in code? First of all, what do you mean by various objects of a class? Do you mean objects that are instantiations of a particular class? And what do you mean in a code? Like, what do you mean by a code? Do you mean how do I use it in a program? Do you mean, like, could you specify? If you're asking how do you save a class in a file, there would be a couple of different ways to do it, but I would say probably the most effective way would be to save it as an XML file. You will be able to hopefully find a library that you would be able to use to convert class objects of particular classes into XML objects. However, that's not really covered in the lecture slides. So yeah. So anyway, I recommend getting SQLite 3 because we're going to be using it. So if you want to follow along, which I highly recommend, you will need to have it. So Data items and their relationships are stored in tables. So the table, you can think of it at this point as the largest thing, the most abstract thing. They're kind of similar to classes, although perhaps more accurate. You can think of, in terms of Python syntax, you can think of a database as being kind of like, it's reasonably similar to a CSV file. So you have a number of records. Those are the rows of the CSV file. You have fields. Those are the individual values inside of the records or the rows. And then you have the table. The table, in our context, would be the CSV file itself. So that's some important nomenclature. So let's set the scene a little bit. Let's imagine that we wished to create a database for a video rental store. As much as, that's kind of an antiquated example in this year 2020. So let's imagine that the things that we need to track are the movies that we have available to rent, the customers, and which customers have rented which movies. This is why we consider this a relational database, because we are essentially creating a relation in a rigorous mathematical sense of the term relation between customers and movies. So we'll need to make 3 tables: a table of movies, a table of customers, and a table of rentals, which will relate movies to customers and customers to movies. So here's an example of some data. We have a table of movies. We have Casablanca, Back to the Future, Monsters Incorporated, Field of Dreams, Life of Brian, and 12 Angry Men. All of them excellent movies, except I can't speak for Field of Dreams, as I've not seen. That's the only one on this list that I haven't seen, so I guess I know what I'm doing tonight. So the database schema, this is another piece of nomenclature for you, specifies the names and the types of the fields of each table. So unlike Python, you actually have to declare specifically what type each field has to be when you're operating with tables. So we've got a few valid types. We've got integers, real values. Notice they're called real and not float. Text. Notice that it's called text and not string. Boolean. Booleans are stored as 0 and 1, not true and false, or false and true in this case. And date, stored as a numeric value, as we had just talked about in the previous set of slides. So, with respect to our movie example, this table's schema is movie ID, which is an integer, title, which is text, genre, which is text, and rating, which is also text. If there are any questions, please feel free to ask them. So, let's introduce SQL, or Structured Query Language. Some people call it SQL. Some people call it Squirrel. Personally, I prefer to call it SQL. I think that sounds better. But anyway, this is a very widely used database query language. It's industry standard. It originated in the 70s. You can use it to perform a large variety of database operations, including fetching records, adding data to a table, modifying data, deleting data. The other thing about queries is, one of the interesting things that you can do with a database is you can say, okay, give me all of the entries that have, movie IDs between these two ranges, and it will comply with that. So the syntax is also mostly independent of the vendor, and by vendor we mean the company that makes the software. So it is highly unlikely if you ever have to use SQL in a real job context that you will be using this nifty little command prompt that we are going to be using to demonstrate SQL. You are likely going to be having SQL in a more advanced piece of software. There are a number of these types of softwares available. There's Oracle, Microsoft SQL Server, MySQL, MariaDB, PostgreSQL, SQL Lite, and MongoDB. But I get ahead of myself slightly. SQL also supports transactions, so these would be things in a more, how you wish to say, things in a more repository. These are like repository operations. So this C02, you guys are less likely to have run into repositories before, but it's a way of managing code. You can basically, it keeps track of all of the changes that have been made to code over a period of time. So if you find you've broken everything, then you can roll the code back to a earlier state, or even just a portion of the code back to an earlier state. So I have question. Objects that have already been created, but you want to compare and extract information. Maybe this is more of a file handling or database setting, but could do similar stuff with classes for objects that have been created already? Well, yes. So, yeah, I mean, the purpose of creating a class is to access the stuff that's inside of it. The manner of access is, generally speaking, you invoke the methods or you use the data, the attributes directly via dot syntax. Oh, good lord. I keep clicking off the video and it stops. There we go. So, yes. Are we going to get tested on databases and SQL Lite? Well, it is possible. It is possible. Certainly, we're in the window for it. This is stuff that could appear on the final, although it's not stuff that could appear. I'm not going to put any of this on test 3, but yes, this is stuff that could appear on the final. So yes, yes. So yes. So does Microsoft Access use SQL? I don't know about Access. Let's see. Does Microsoft Access use SQL? Yes, relational database programs such as Microsoft Office Access use SQL to work with data. So, can confirm. Yeah. So, recently, cloud storage has become a thing in recent years, and these are not relational databases, so you're not using SQL for these types of databases, but generally speaking, SQL is a very useful thing for a large number of applications. So most of these database programs, including Microsoft Access, as it turns out, use SQL for interacting with the database. SQL Lite is a variant of SQL that is slightly easier to learn and just get started with, and that's the one that we're going to be focusing on over the next few slides. So it's a widely used serverless relational database manager. Because it's serverless, it means that the database files are stored locally. So it's a manner of creating a database on your own computer without having to set up a server or run additional background services. Like right now, this instance of Jupyter is actually a server that is running on my own system that I can log into under the localhost 8888 URL address. So there's no need for that. It's not as efficient as large. It's not as efficient as the larger database programs, and doesn't really support multiple users. But it's simple. The objective of this course is it's not even necessarily to make you a good database user. It's just to introduce you to the concepts that are required in order to manage databases so that you have the vocabulary for it. So that if you were to, when you bump into database type problems in the future, you'll have some leg to stand on. You'll know, oh, I know roughly what this is. I remember that from that first year programming class with the professor who was absolutely bonkers. So, as I said, I showed you guys how to get it installed. You'll want to go to the sqlite.org/download page and get the one that's relevant for your operating system. So, in order to work with SQLite, this is how you would do it on the command line. If you are loading it from Windows, as I am, then it will actually load you directly into the command prompt without specifying a file name. So we want to .open videostore.db. There you go. So now we are storing things in... Oh, I misspelled it. Oh, well, I guess it's just videostro forever now. So if you take a look, right here, you'll notice we have in fact created a database file, videostro.db. And it contains nothing, 0 kilobytes. So, if you want some help on how to use it, .help. There you go, lots of help. And if you wish to quit the application, you type .quit. Very cool. So, let us create a table. When you create the table, you, at the same time, enter in the schema for the data that's going to be in that table. So, for example, let us create table movies. We have a movie ID, which is an integer, comma. We have a title, which is text. We have a genre, which is text. And we have a rating, which is text. Ta-da! So we have created a table called movies. So this makes the table. There's also a difference. There are a couple of options that you can specify within the encoding, within the typing out of the schema that sets various options with respect to the data fields. So it's useful to set something as a primary key. The primary key is a unique identifier, and it's always useful for database entries to have something as a unique identifier, even if the only purpose of that field is to be the unique identifier. You can imagine within the context of the video store example, video stores will often have multiple copies of a particular movie, a popular movie, like Star Wars or something. So you can imagine something like the title of the movie is not going to be sufficiently unique to use as a primary key. In our example, we are actually having a specific movie ID which is unique to every entry in the database. Additionally, we can make some of the fields required. So within a database, there is support for incomplete records. So when you create a record inside of a database, you don't necessarily need to enter all of the information that's in the schema. However, if there are some elements of the schema which absolutely have to be there, for example, the title of the movie, don't necessarily need to know what the rating is, but you need to know what the title is, then you can use the required keyword. So if we are to do that, if we are to apply that methodology to the previous example, we make the movie ID primary key, and we make the title required. Error, tables already exists. So delete tables, movies. Oh, that doesn't work. Ha ha ha. Just delete it. So, oop. Copy. And, oh, I don't have copy paste. What a tragedy. Create table movies, movie ID integer, primary key, title text, required, genre text, rating text. And I've missed something, have I? A semicolon. Ah, that probably was the problem before. How much time is test 3 expected to take? Well, that's kind of an interesting question because the tests, generally speaking, take people a very sort of wide range of write times depending on their level of skill. So, oh my god, you guys are really... It was because I showed you how many days there are remaining to the test, isn't it? So, how much time is test 3 expected to take? Probably a couple of hours. I think a couple of hours is reasonable. What is the policy on MSAFing the upcoming test? I.e., what happened to the 10%? Well, I'm going to say the same thing that I always say whenever anybody asks me about MSAFing anything. Please ensure that you are using the MSAF for... Please ensure that you are using MSAFs for the purposes of medical accommodation or personal injury or personal mental health and well-being. Please do not use MSAFs as a means of gaming the marking systems. That said, the policy on MSAFing the upcoming midterm, if you use an MSAF, the 10% attributed to that midterm will be applied to tests 1 and 2. So test 1 and test 2 will both become worth 15% of your final grade, and test 1 or test 3 will sort of be worth 0% of your final grade. But yes, anyway, so that's time. We'll continue talking about databases on Thursday, and in the meantime, I will stay online for a little bit in case anybody has any more questions that they might want to pump me for information on the midterm, etc. And aside from that, yes. So ends the lecture. Can I please post the instructions for downloading SQL Lite on Avenue? Yes, I can absolutely do that. That is, yep, I can do that. You say that cloud storage isn't a relational database. Why is that? I actually don't know enough about cloud storage to be able to tell you that, to be able to answer that question. I apologize, to be honest with you. Databases are not an area of expertise of mine. Networking stuff in general is not an area of expertise of mine. So, sorry. Yeah, yeah. So, a relational database is a very specific means of interacting, right? What little I know of cloud storage is that it's more along the lines of just generalized file storage rather than acquiring specific like spreadsheet type information. When you're using an SQL database, you are definitely using spreadsheet type information for sure. Okay, hit me. We have a question. I also have a question about submitting homework via Avenue. Go for it. Yes. Well, let me think. Let me think. Let me think. Let me think. Um, so, like, are you inquiring about an assignment that you've already submitted, or are you inquiring about a assignment that you might submit, if or might submit in the future? If you're inquiring about an assignment that you submitted, that you are going to submit, please make sure that you're using your Mac ID as the name of the file. If you are worried about a file that you have already submitted that does not have your Mac ID as the file name, don't worry about it. There will be a certain degree of forgiveness with respect to that the first time around. Also, we have a general policy at the moment of not being too hard on people over stuff like that. So yeah, like although a lot of the processes that are going on here in order to mark the mark the assignments and all of that stuff, although largely a lot of automatic processes are being used, these processes are being run by human beings, and those human beings are intelligent, far more intelligent than the computers. And if you have any follow-up questions with respect to that, please send me an email. But yeah, anyway, take her easy, folks. Don't go crazy out there.